Hi, did you know EDEXCEL made practice papers? Well, they do, and they're a fantastic resource. They are full sets, papers 1, 2, and 3, and 80 marks on each. So, how many have they actually made? Loads. I mean, loads. There are 144. I don't think anybody would need that many. Anyway, I am making it my mission to do worked solutions for as many as I can. Obviously, the goal is all 144. I do work full time though, so I'm going to be creating them and pushing them out as quickly as I can. So watch the channel because new videos are going to land all the time. Now, to use the papers, I would recommend downloading them, sitting quietly, cracking on with it, and then coming back to do the marking. You've got all the solutions with walkthrough examples. So if anything's gone wrong and you need to see the steps and the methods, it's all going to be there for you. Now, for grade boundaries on the end screen, I've provided some percentages as guide only. No one knows what the grade boundaries will be ever. Anyone telling you are really just trying to give you a guide, and mine is no different. I have gone for the highest percentages we've seen so that we are reducing our risks, but it gives you a goal. It gives you something to head for. And I think that is really, really useful. So once you've got your score, check out the end screen, and that will also give you an idea of your grade. Now, if you're really struggling, if you're finding that you're sitting down to do the papers and they're not going very well, but you like the way that I explain and walk through the questions, then I do have some courses that are available. They are in the description below, so you can just click on that link. If you are somebody that wants to be studying and gaining the higher grades, my grade 6 course is currently free here on the channel. So do go and check that out. The course is designed to help you develop your critical thinking skills. So whilst it's all labeled up as grade 6, because we use a lot of those topics to help us, actually what you're going to really get from that is those topics, but the critical skills that you need. Okay, well, good luck with your studies. This will make a great addition to your revision. If you like what we're doing, please hit that like and subscribe button. That'll hopefully push the video out to more people and more people can benefit from it. Obviously, comments are great. So yeah, just good luck. Revising for a GCSE maths, it's going to be tough. So I wish you well. Okay, so we're going to write this number to the nearest 1,000. I like to take the 3 zeros and place them going backwards underneath those 3 digits. That tells me that I'm going to be cutting here. If that's 5 or more, which it is, I add 1 to that side, giving me that as a final answer, 18,000. Now, writing this as a fraction isn't the simplest of questions. I think the best way to do this is to consider your place values. You know that that is unit. This is your tenths, hundreds, thousands. The last digit is in the thousandths column, and we've got 19 thousandths. So that's how you would do that one. So we're being told the probability that it will rain is 0.65, and what is the probability that it won't rain? Well, those two events add to 1. So 1 take away the will rain event gives us the not rain event. To draw the isosceles triangle, I mean, there are obviously a lot of different triangles that we could draw and a lot of different orientations. I could have my base this way and build up my triangle. I could equally go off in this direction and build it. So when I give you the solution, I'm just giving you an example of the solution. So I'm going to do an even number of squares because it will make it easier for me. I'm going to go to the center point, and then I'm just going to, I could be here, 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 here. It really doesn't matter. So I'm just going to choose there, and then I'm just going to draw up either side, and that guarantees those equal edges that you need for an isosceles. Okay, an odd number from the list would be 5 or 7. Just choose one of those. The square number is 4. 2 times 2 is 4. A multiple of 3 would be 6. 6 is in the 3 times table. And a factor of 10, you could put down 2 or 5. Both of those multiplied to make that number 10. Okay, so we've got a television program starting at 17:55. It's an hour and 20 minutes long. What time did it end? So the time is 17:55. If I add an hour straight away, I'll be at 18:55. And then I want to add 20 minutes. I'm going to break that up. I'm going to add 5 minutes first of all, just to round that time up. And then I'm going to add that last 15, and it will take me to 19:15 as my final answer. And this method, just sort of working it through a bit like almost being on a vertical number line, is the best way. I can't stress it enough. If you just put this into your calculator, it will go wrong. All right. Sometimes it doesn't, which lulls you into a false sense of security, but it's likely to go wrong, certainly on an exam style question. Okay, so we're starting to watch the program after it's already begun. We've got to work out how much of that program has been missed. Program started at 17:55. He doesn't start watching it until 18:34. So I'm going to add 5 to get to the 1800, add 34 to get to 18:34, and then I can just add those minutes up. So he is 39 minutes late to the program. Okay, so we've got some scale reading to do here. We've got to write down the weight shown on the scale. I can see that the scale's gone 24 to 26. This is halfway, so my answer is 25. There's an extra charge to pay when the weight of a bag is more than 23. The weight of Grant's bag is 19.5. He does not want to pay the extra charge. So how much more weight can he put in? Well, we've got to work out that difference then. The most he can have is 23. Take off what he's already got, and you've got 3.5 as what he's got left to be able to put into his bag. Nina has 2 bags. The weight of each bag is 20. 1 kilogram equals 2.2 pounds. What is the total weight of Nina's bag in pounds? Well, we'll get the total of the kilograms first, which is 40 kilograms. And then if you've seen any of my videos, you'll know I love a fact. When the question's got a fact, we put it into our grid. So 1 kilogram is worth 2.2 pounds. I've got 40 kilograms. So it goes in the in the kilograms column. You multiply the diagonal, you divide by the one in the corner. Now, dividing by 1 isn't going to do anything. So really all I have to do to finish this off is 40 times 2.2 in the calculator, and that's 88 pounds. And this is just about structuring the numbers so you know what to do. So if you can't see what the maths might be, this really makes a difference, and it works wherever there is a fact. Okay, so we have a number machine. We've got the number of people going in. It gets divided by 4, then it gets 3 added, and you've got your number of boxes. There's going to be 40 people, so we are here in the machine. 40 goes in, divide by 4, which is 10, and then add your 3, and you've got an answer of 13. For a different party, John needs 9 boxes of orange juice, and we've got to work out the number of people. So we're going to be going backwards through this number machine. And when you go in the opposite direction, you use opposite signs. So I am starting with the number 9. I'm hitting this box. And the opposite is to take away. So 9 take away 3 is 6. And then I hit this box. Opposite is to multiply. So I'm going to be timesing by 4. And that is going to give a final answer of 24. Okay, so we need 26 cartons of orange juice as cheaply as possible. So buying in packs of 3
is more economic. So we want to buy as many as we can. So 26 divided by 3. Remember, you've got your calculator. Just pop it in. It gives you 8.66 and on it goes. That tells me that if I buy 8 packs, 8 times 3, there's 3 in each pack. That tells me I can get 24 by buying 8 packs. So let's work out how much that's actually going to cost. So 8 packs times through by 90 pence is going to give me 720 pence. I'm going to get that into pounds in case I decide I want to give my answer in pounds. I am too short. I've got 24 and I need to buy 26. So I'm going to have to buy 2 single cartons. So 2 times 38 is 76. And then I add it on. And as I say, I can either give my final answer in pence or I can give my final answer in pounds. I'm going to actually add it on the pounds to get £7.96. Now, what is important is that we include our units. However we've chosen to do it, we've got those units because there's no dotted line and there's no units given to us on the answer. So yeah, just make sure you're clear about your units. Okay, so Alan is going to save 10% of his wages each week. So that's the first bit that we need to do. We need to work out 10% of 240. Now, most people will divide by 10 to get that, and our answer is 24. We got to work out how many weeks it's going to take to save the money. So we want 216. We're saving 24 every week, so we'll divide through by the 24, and we get an answer of 9. So the answer is 9 weeks. Okay, question 11. We need to really be representing these numbers in the same way rather than all these equivalent ways. You've got your calculator. So I would recommend going into decimals. Putting in 2/3 would give you 0.66 and on it goes. 13 over 20, 0.65. Obviously, these two are already decimals. Now, this one, you're either going to just know that it's 0.7. If you don't, then what you need to know is that percentage means out of 100. So you put that fraction in and it tells you it's 0.7 on your calculator. And now it's really easy to see what order to put everything in. The only additional thing that I would say is if you look at this decimal, all the other decimals, we've got 2 decimal places, but this one and this one doesn't have that. It may be useful to just add an extra 0 so they're all the same, and then it's easy to see that that is 60, that is 65, that is 62, and you can read it like that to make it easier to put them in order. I wouldn't include that extra bit on my answer line though. So our order is as follows. And you can see that I have reverted back to the numbers that they gave in the question on my dotted line. Okay, I've got 4 d squareds, whatever they are, I've got 4 of them. And when I take 6 away, I will have -2 of them. I'm then being told to add 5. When I add 5 to -2, I get to 3. So I have got 3d squareds. The power isn't going to change. Just see that as an object that you're adding and taking away from. For the next one, I've got 7 x's, and I'm being told to take away 3 of the x's. So that will give me 4x. I've got 5 y's. I'm being told to take away 8y. That will give me -3y. And that's my final answer. 4x take 3y. For part B, if I want to know what x equals, I've got to get it on its own. So we're going to pick up that take 5, throw it on the other side, it will land as add. That tidies up to give me this. And then this is a times on that side. So when it comes across, it will land as a divide. Pop that in your calculator and you get 3.5. Okay, so we've got buckets A, B, and C. They're all the same size. Bucket A is 2/3 full, B is 3/4 full, and C is 5/6 full. And we want to know if there is enough rainwater in C to pour into A and B and completely fill them. So let's think about filling A and B first of all. I'm going to need 1/3 to fill bucket A, and I'm going to need 1/4 to fill bucket B. I have 5/6 in C. If I take off 1/3, that's what's going to go into A. I can just put that straight in my calculator, guys. I don't need to mess around with my non-calculator methods because I'm on a calculator paper. So you can just throw that straight in and it is going to give you 1/2 as your answer. So there's still 1/2 left here when I pour some out to fill A. B is 3/4 full. I only need 1/4. I have 1/2. I need 1/4. Yes, I have enough. Okay, I've got to work out the size of angle X. Now, if I had this angle, I would be able to solve it really easily using my straight line rule. So now I'm going to concentrate on this one. I can get this angle because it's inside a quadrilateral and I have all the other angles of that quadrilateral. So I am going to be doing 360, the total angles in a quadrilateral, take away all of my other angles. Put that in my calculator and I get 58. It doesn't matter how you do it. You can add that up first, take the total away, whatever works, okay? Now, on a straight line, 180 degrees, take away the 58 that I've just worked out for that angle there, and I've got X as 122 degrees. So we've got some information about Peter's walk and we have to work out the average speed. So we need to kind of clock these key words. We've got a period of time, we've got distance, we've got speed. So our speed, distance, time triangle should automatically get triggered. Distance is on the top and the distance was 15 miles. Time is on the bottom. Pop that into your calculator and you've got 2.5 miles per hour as your answer. Sunita says that Peter walked more than 20 kilometers, and we've got this fact here that 5 miles is equal to 8 kilometers. So I'm going to put my fact in my grid. So 5 miles is 8 kilometers. We know from part A that he walked 15 miles. So I put that 15 in the miles column and then I multiply through by the diagonal and divide by that corner. I will write that out properly for the examiner so the maths is clear. Into the calculator, and that is 24 kilometers. That is more than 20, so she is right. Yes. Got a angles crossover question. We've clearly got the diagram to look at. They've also given the information from the diagram in worded form. So this isn't additional information, it's information that we can already see. If you're not someone that's brilliant at angles, then a top tip is to use your tracing paper that you're allowed in your exam and literally trace the diagram. That way you've got a spare copy of the diagram that you can scribble all over, try different ideas out on. But also the drawing action helps you spot things that you might not see when you're just looking. So physically drawing it out does help you see more of the information. Okay, we are trying to find X. And the first thing that I'm going to do is use the 76. I can see that the 76 is sitting on this parallel line. So if I follow from this parallel line up to the next parallel line, then I know this angle, which is 76, will tuck in with this angle here. So I know that is 76.
I've been told that I have to give reasons for my answers. So I'm going to write them out as I go. So I've used alternate angles. I know it's alternate because I've got that Z shape. And I've used this notation here, BAC. That means I've started at B to A to C. Those two lines create that angle. All right, so that's the notation that I'll be using throughout. Now I'm going to focus in on this 54. They've given it to me, so it must be helpful. That 54 is inside this triangle with the right angle. So I'm going to use that to help me find this angle here. So 180 for a triangle, take away the angles we know, gives us 36. And I'm marking this on the diagram so I can clearly see it. I now have everything I need to work out x. I can see that all the way across is 76. This little bit here is 36. So 76 take 36 is the mass. And that is my answer. Okay, so we're being asked to complete the table of values for the y equals x squared minus 4x minus 2, and then draw the graph. If you know how to do this in your calculator, then use your calculator. If you don't, then that is something that you really want to learn because it's super, super helpful. If you don't know how to do it, you're going to be doing it the long way. So you've got y being equal to x squared minus 4x minus 2. If I do this section of the table, I'm being told x is 3. So that's going to give me 3 squared minus 4 times 3 minus 2. And when you work that through, you get a result of minus 5. So you can pop that into the table. You would then repeat the whole process with the next missing value. I've used the calculator, so I can just fill them all in. We then have to take the coordinates that the table gives us. So that end one, for example, x is 5, y is 3, and we will plot that onto our graph. And we will go through and plot all of those coordinates and draw in the graph. Okay, now you can see that I have not gone through absolutely perfectly, but I have done a good enough job to get the marks. They want to see that you are trying to draw a curve, so make sure it stays curved at all times and it runs through. Sometimes just turning the paper around and doing it at a different angle makes it easier to do that drawing. Now there is a part C. We've got to use our graph to estimate the values of x when y is equal to minus 3. The line y equals minus 3 is here on our graph. Our values are on the x-axis where these cross each other. So I would literally just be going up and reading where they come in. So x is 0.3 and x is 3.7, I would say I've got on that graph there. Now, they do allow a slight range because you have to remember, if this is being drawn freehand, then yours might not look exactly like mine, and therefore our results may differ slightly. So if you've had a answer between 0.2, put the point in, and 0.4, that would be acceptable, and 3.6 to 3.8 would be acceptable. Okay, so we've got information about the average adult spend in 2008. In May 2008, Katie spent a total of £425. She spent £48.45 of the 425 on food, and we've got to compare the percentage of that in the table for the average adult. So we'll set this up as its fraction. So £48.45 out of her total 425 is what she spends on food. Obviously, I don't want a fraction. I want a percentage so that I can make a comparison. So I'm going to times that through by 100.
Calculator tells me 11.4%. So Katie spent 11.4%. I need to compare that with the average adult. The average adult spent 11%. So Katie spends 0.4% more. Okay, so we've got a semicircle and a circle that have created this shaded area that they want us to find. Now, there are a couple of ways that you can work around this problem to get to the answer. So I'm obviously just going to demonstrate the one that's obvious to me, and that's how we do our maths. We do the one that we can see within the problem. Now, I'm actually considering this section of the diagram only because this section of the diagram has my shaded bit. So I'm kind of going to ignore this side. So in the problem, I've got a quarter of a very large circle. So I've got a circle here with a diameter of 20. That's the original semicircle. And I only want a quarter of that circle. I want this section here. So I am going to be doing pi r squared, which gives me the area of a full circle, but I'm going to divide it by 4 because I only want a quarter of it. Now I need to be careful. I've got the diameter, not the radius here. So I need to half that. So I've got pi times 10 squared divided by 4. And that gives me 25 pi. Now I could change that into the decimal, but if I do that, I've got quite a complicated number to then have to work with. So I'm just literally going to leave 25 pi as it is for now. Now I'm going to look at the circle. So I've got the circle, which has a diameter of 10, and I want all half. I want all of that section. So that is going to be pi r squared divided by 2. Now remember to use your radius, and that gives us 12.5 pi. Now to get the shaded region, I'm going to be taking the quarter, and it's almost like imagining try and use my lights. You're taking this quarter, and it's almost like they're punching this out of it so that it's gone, and you're left with this shaded area. So the last step is to take away. So we've got 25 pi, take away 12.5 pi, which is going to give us 12.5 pi. And now I'm going to look at my decimal, which is 39.269. On and on it goes. They're asking my answer to be to 1 decimal place. So my final answer is 39.3 centimeters squared. Okay, so Chris works in a cafe and he's recorded the number of customers sitting at each table. So let's just interpret the table quickly. He's got 4 tables with no one sat at them. He's got 5 tables with 1 person sat at it, and so on and so on. We got to work out the total number of tables. So that is this column here. We need to add those together. Do that in the calculator and you get an answer of 30. This is a 1 marker, so you're not going to get anything for method marks. But what I would say is maybe add it up twice. Add it up once and then double check you didn't do anything wrong in that calculator. So you've definitely got the right answer. Part B is asking us to work out the total number of customers sitting at each table. So let's go back to this table a sec. I don't have any customers sat on these first 4 tables. So there's literally no customers there. On these 5 tables, I've got 1. So 1 times 5 is 5. And that multiplication is what's going to happen throughout. If I've got 10 tables and there are 2 people on each of those 10, then in total, there would be 20 people. And it's a times that is happening here. So I'm going to multiply through all of these rows, and then I'm going to add them up. So I've got a total of 63 customers. That is my answer for B. I'm then being asked for C to work out the mean number of customers sitting at the table. Mean is add them all up and divide by how many are there. And actually, this question has helped us because it's doing the maths as we go. Add them all up. There it is. I've added up all my customers. And we've got to divide by how many are there. So how many tables are there? So for part C, we would literally do 63 divided by 30. And the mean number of people at each table is 2.1. Okay, there are only red beads and green beads in a bag. The ratio of red to green is 5:9. So I'm just going to pop that there so it's clear and easy for me to see. I don't have to look at that sentence again now. What fraction of the beads are red? So we've got 5 that are red out of a total of 14 that are there. There is a total of 84 beads. How many of the beads are green? So if I've got red to green being 5:9, in the ratio, I have a total of 14. In the story, I have a total of 84. How do I get from 14 to 84? I times by 6. So I would do the same on this side. Now, I only need to do the green. So 9 times 6 is 54. So 54 green beads are in the bag. So Susie is going to put some more beads in. There will still only be red and green, so we know we're not having a different color. She wants to have twice as many green as red in the bag. So what beads should she put in? What do we know already? We know that we've got red and green in a ratio of 5:9, and that there are 30 red and 54 green to make that 84. Now, at this stage, she is adding more so that she has twice as many green. So if we look at the red, there's 30. For there to be twice as many, we need 60. And to get from 54 to 60, we would need to add 6 more green. Okay, we've got a right-angled triangle. They're making that really clear. And we are having to work out a missing edge. We've been given an angle and another edge to help us solve this. This is trigonometry. And for those of you sitting your exam in 25, 26, 27, you will be given a formula sheet. So you will have this information, and I couldn't recommend highly enough to make sure your methods tie in with your formula sheet so that you can easily use it. It becomes a proper aid that will help you in your exam. So if I take a look at my formula triangle, my angle is here. That is called A, and I have that in my question. So I now know that the opposite edge is A. My right angle points to A and B, so I know that's B and that's C. I don't need A in this problem. It's not got any information on it. C, I'm going to use because I have the value. B, I'm going to use because it's what I'm trying to work out. B and C as a combination is here in the middle. So I'm going to be using cos to help me solve this. I am still going to use my formula triangle. So cos A is on the bottom, B is on the top of the fraction, C is underneath. Now the capital letter A is my degrees. So I'm going to rewrite this now as cos 32, B is x, and C is 8.5. I always write x first and then my equal. So I've done the x. I've got these two side by side which means they are going to get multiplied. Your calculator is going to open a bracket. Make sure you close it. If you don't close it, it will go wrong. You pop that in. Calculator's giving me 7.208 and on it goes. Question says 1 decimal place, so I'm going to cut it here. No rounding required, so just 7.2 centimeters for my final answer. And that's it. Now, this is the last paper in the set. So if you've started here, do go back and use the paper 1 and the paper 2 so that you can get an idea of an overall grade. And like I've said, if you've seen these videos and watched to the end before, we are posting these every single week. So you are never going to be short of a practice paper to do.